let's take a look at the estimating quantities. Quick little video, revisit what we did in class today, in case you get stuck on working either the examples or some of the problem set. Okay, so I'm going to run through this very quickly. Our essential question is, how do we estimate numbers, okay, using division, especially if they're really big ones? All right, so what strategies are we going to use? We talked about this. We are going to change them into powers of 10, right? Describing numbers using place value, powers of 10, and then we're going to divide. All right, so here's what we did with that problem in New York. All right, what we did in population is 1723 is we took 7,248, right? And we looked at the power of 10, and we looked at the power of 10 that exceeds it, right? So the 7 in this problem is, right? So 7,248, right? This right here is the power of 3, 10 to the third power. So we looked at this as 10 to the fourth, okay? Because that's the next one that exceeds it. Then we looked at the population in 1870 with 292. All right, and we looked at this one and we said this is 10 to the fifth power, right? Third power, fourth power, fifth power, 10 to the fifth power. And so we said the one that exceeds that is 10 to the sixth, okay? Then we looked at 1860. We then looked at we looked at 10 to the, all right, 1860, right, compared to, 1870 compared to 1723, all right, and so we divided that. So we said how many times bigger was it, and we looked at this, and we decided that this is the same as 10 to the 6th minus 4, so that's 10 squared, right, so it's 100 times larger. Right? New York was 100 times larger in 1870 than in 1723. All right? Excellent. Moving right along. Okay, then this is the exercise that's actually in your book, okay? So you looked at this one again, the credit card debt. We wanted to rewrite each number to the nearest power of 10 that exceeds it. Remember, this is the one that's bigger, all right? So 7,122, and then we have 16,755,133,009,522. Okay, we're looking at the significant digit here, right? So this one is 10 to the third. This one is 3. Remember, I'm starting at 1,003. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that one's 10 to the 13. So the one that exceeds credit card debt is 10 to the fourth power. That's the one that exceeds it. And then this one is 10 to the 14th. Okay, then we compared it. So we did 10 to the 14th divided by 10 to the fourth. Same base. Division means I can subtract exponents. 14 minus 4. So I get 10 to the 10th power. Okay, so we know that the credit card debt is 10 to the 10th times bigger than the personal credit card debt. Okay. All right, moving on. Come on, grab it. Sorry, I'm trying to get this. There we go. This thing to move down, and it wasn't cooperating. Okay, so let's talk about New York again. Okay, they talk about New York City, rounded to the nearest million, and then we did example 2, which is write a single-digit integer times the power of 10, and then we did it as New York State. Okay, so the New York City, we looked at that. That's this currently, so that written as 8 million. That's how we rounded it. Okay, and then that written as a single digit times the power of 10 is 8 times 10 to the 6th power, right? 8, right? This is in millions place, so 8 million. Right? Then we looked at the population of the state, which is that one, and that goes to about 20 million, all right? Which is 2 times 10 to the 7th, right? 10 to the 7th is this power right there. So we have 2 of those. And then what we did is we said, let's go ahead and let's compare them. Let's compare these values. Okay, so we're going to estimate the difference. Right, so what we did is we said this is 2 times 10 to the 7th, and we're going to divide it by 8 times 10 to the 6th. Right, well, 2 doesn't divide nicely by 8, so we changed it. Remember, we looked at this, so instead of saying 2 10 millions, this is 20 millions. And then we did 8 times 10 to the 6th. So from here, okay, I have this, right, 10 to the 6th divided by 10 to the 6th, that's going to equal 1. Another way you could look at it, this is 10 to the 6th divided by 10 to the 6th is 6 minus 6 is 0, right? And we know that 10 to the 0 is equal to 1, right? That's part of why it is. So then I get 20 over 8. Okay. Well, if I divide this, both of these have a common factor of 4. So I'm going to divide the top by 4 and I get 5. And I divide the bottom by 4 and I get 2. So this ends up being 2.5 times, right? Or 2.5 times bigger. So New York State is about 2.5 times bigger than the population of New York City. All right. Let's do another one. Okay. Whoops. So, example 3, there are about 9 billion devices connected to the internet. If a wireless router can support 300 devices, about how many wireless routers are necessary to connect to all 9 billion devices wirelessly? Because 9 billion is a very large number, let's do it as a single digit integer of 10, okay? So this is going to be 9 times, and what's billion, right? Billion. Okay, so let's see. We know that 3 is 1,000, right? 10 to the 3rd is 1,000. Okay, and 10 to the 6th is million, and 10 to the 9th is billion. Right? Remember, it goes by threes. Billion. So this is 9 times 10 to the 9th. All right. Now, laws of exponents tells us that our calculation is easier if we also express 300 as a single digit times the power, right? Because then I can use my powers. I can divide very nicely. So we do 3 times 10 to the 2nd power. That's hundreds. Well, now we divide. Okay, and now I'm going to get 9 divided by 3, okay, times, right, and then it's going to be times 10 to the 9 minus 2nd power. All right, well, what does that equal, right? So that's going to equal 9 divided by 3 is 3, and then I got 10 to the 9th minus that, so I got 9 minus 2, so 10 to the 7th. Okay, so then what is that number? 10 to the 7th. Well, we know that million, right, is 10 to the 6th. So this is 10 million. So 3 10 millions is also known as 30 million. So we need 30 million wireless routers. Wow, that's a lot of wireless routers. Okay, I'm sure Netgear and Linksys would love that. All right, next. Let's see. I don't remember if there's, I think, is there more below here? Nope. So one more example, okay? We're going to talk about this one. We started talking about this a little bit in class. There's 3 million students attending school, kindergarten through 12th grade in Illinois. Let's do that as a single digit number. 3 times 10 to the 6th. The average number of students attending a middle school in Illinois is 8 times 10 to the 2nd. We want to compare them. So we're going to compare them using division, okay? Well, 3 and 8, right? 3 doesn't divide by 8, so I'm going to change this. So I'm going to make this 30 times 10 to the 5th, okay? So 3 million, okay? This is 10 to the 6th. This is 10 to the 5th. This is 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, 10 to the 0, right? So if I look at it here, I get 30 of these. Okay, so 30 times 10 to the 5th divided by 8 times 10 squared. Okay, well now I've got 30 divided by 8 times 10 to the 5 minus 2. Well, what is 30 divided by 8? Okay, well let's find common factor of 2. So I get 15 over 4 times 10 to the, this will be 3, so 1,000. And then we're going to look at this and we're going to say, okay, 15 divided by 4, that goes in 3 times with 3/4 left over times 10 to the 3rd. So it's about 3 3/4 times 1,000, right? So almost about 4. So we'll say about 4,000 times bigger, okay? All right. Exercise 3, right? This is the one that I wanted you to do on yours, okay? I'd like you to do exercise 3, and I'd like you to try to do exercise 4, which is not this one, okay? This one is one we'll do in class tomorrow, okay? You could do example 4, okay? and then you will do the problem set. And that will be, I'll check that in tomorrow.